Hello students, welcome to today's session of chemistry. As you all know, we have started studying fifth lesson of your syllabus, that is electrochemistry. Before starting today's session, we will just revise what we learned in the previous session. In the previous session, we started study of galvanic or voltaic cell, and in that session we learned all the basic things related to the construction of a galvanic cell. So let us revise some part of it. What is galvanic cell then? It is a cell in which a spontaneous redox reaction takes place and which converts chemical energy into electrical energy. And hence, to carry out that spontaneous chemical reaction, we require a cell. And that galvanic cell is made up of two half cells. Each half cell consists of a metal strip dipped in the solution of its own ions of known concentration, and such that we take two different metals dipped in the solution of their own ions of known concentration, and we connect them externally by using conducting wire, and in between that we connect voltmeter. And internally, these two half cells are connected by a salt bridge. And what is salt bridge? And what are the functions of salt bridge? That also we have studied. Salt bridge is prepared by filling a U-tube with hot saturated solution of the salt along with agar-agar solution. And after cooling, that agar-agar solution converts into a gel. Hence, when we invert that U-tube to connect two half cells, the solution doesn't comes out as we close the ends by using glass wool plugs. And salt bridge functions as it prevents mixing of two solutions, it provides an electrical contact between two solutions, and hence it maintains electrical neutrality. Now, let us begin with today's session. Now, in today's session, I am going to tell you about the formulation or short notation of galvanic cell. What does it mean? A galvanic cell is represented by a formula or short notation, we can say, that includes electrodes, aqueous solutions of ions, and other spaces which may or may not be involved in the cell reaction. But it is required to construct a cell. It may not be involved in cell reaction. That means we know galvanic cell is made up of two half cells. One is anode, another is cathode. And different metals we are using as anode and cathode. Hence, we can represent all the galvanic cell and the reactions in it by a short notation. And how to write it or how to understand it, that we are going to learn about. There are some conventions which are used to write the cell notation. So, the following conventions are used to write the cell notation. We'll see one by one, try to understand each and everything, and hence it will become easier for you to write a cell or a formula of a cell. So, the first point or the first notation we can say, the metal electrodes or the inert electrodes are denoted by vertical lines placed at the ends of the formula or the short notation. The anode is written at the extreme left and cathode at extreme right. This is first notation. Now let us understand what does it actually means. Now the first important condition while writing a formula is you have to write anode at the extreme left and cathode at the extreme right. That means suppose we have taken zinc metal dipped in the solution of zinc ions, and if it is anode, then we have to write zinc at left side. And another metal which we are going to use as cathode, that we have to write in extreme right. That means at the middle position or interior position, some other things are there. So first condition, anodes and cathodes, where they should be written. And the second condition it is given here is the metal electrodes or the inert electrodes are denoted by vertical lines. How the vertical lines we have to write, that I'm going to tell you later when we learn actually, when we write actually the formula. Okay. Now second condition or second point. The insoluble species, if any, or gases are placed in the interior position adjacent to the metal electrodes. Suppose we use gaseous electrodes. That is also one of the type of the electrode. That means hydrogen gas or oxygen gas can be used as an electrode. As we are saying that we are going to dip metal strip in the solution, then how hydrogen gas can be used? For that, a neutral or inert electrode is used. That means platinum strip is taken, and on that hydrogen gas is adsorbed. And that also can be indicated in the notation as well. That means we are writing a formula. And suppose we have used hydrogen gas as anode, then hydrogen gas only cannot be used. For that, an inert electrode is required. So that also can be mentioned at the interior position adjacent to the metal electrodes. That also we will take an example and learn about it. Okay, so this is second condition. Now the third condition. The aqueous solutions of ions are placed at the middle of the cell formula. Now the cell formula, it is from left to right. To the left side there is anode. At the middle position, the aqueous solutions of the ions, and then at the right hand side there is cathode. So the aqueous solution, because we are going to dip that metal strip, that anode, in the solution of its own ions, that also should be mentioned. That is mentioned at the middle of the formula. Next condition. A single vertical line between two phases indicates the phase boundary. It indicates the direct contact between them. What exactly it means? For example, if we take zinc, again I am taking the same example. If zinc is dipped in the solution of zinc ions, that is zinc dipped in ZnSO4, at the time we should separate Zn and Zn plus 2 by a single vertical line. That means Zn, single vertical line, and Zn plus 2. You have to write like this. What it indicates? That single vertical line indicates the phase difference, because Zn is in solid state and Zn plus 2, that is in aqueous medium. So phase difference is indicated by that vertical line, and also it indicates the direct contact between them, because we are dipping Zn in Zn plus 2. The phase is different, but they are in direct contact with each other, and that all those things are represented by a single vertical line. That means Zn vertical line, Zn plus 2. It indicates Zn is dipped in the ions of Zn plus 2, or Ag vertical line, Ag plus. That means we are indicating the direct contact between the metal and its own ions by a single vertical line. Understood? Now, the next point. A double vertical line between two solutions indicates that they are connected by salt bridge. That means, now suppose for the left side we have taken zinc ions. So we will write Zn, vertical line Zn plus 2. Then we will write double line or double vertical line, parallel line. That double line indicates the difference between anode and cathode. Because at cathode, suppose we have taken copper ions, Cu plus 2 dipped in Cu. The Cu plus 2 and Cu, there is one single vertical line in between them. But Cu and zinc, in between these two, there should be a parallel vertical line that indicates indirect contact, or we can say contact through salt bridge. So anode and cathode are separated by double vertical lines. Next point. The additional information such as concentration of solution and gas pressures is also given. Suppose we have taken gas as the anode or cathode, then their pressure must be mentioned. And in case of solutions, the concentration. Suppose Zn is dipped in the Zn plus 2 ions of 1 molar concentration, that 1 mole is written in bracket below that Zn plus 2 ions. So, other information related to the construction of the galvanic cell is also mentioned in that formula. So the formula is complete in itself, that will tell you everything about the galvanic cell. What is anode, what is cathode, what is their concentration, what is their pressure, everything about that cell. And now the next point. A single half cell is written in the order. A single half cell is written in the order. How that order is? Aqueous solution of ions first and then the solid electrode. There is also one more rule. Single half cell if you want to write, then you cannot write Zn vertical line Zn plus 2. It should be written like Zn plus 2 vertical line Zn. That means that ion comes first, then vertical line, and then the solid electrode. So these all are rules to write a galvanic cell. If we follow these rules, then the correct notation, if we write from that correct notation, easily we can write cell reactions as well. Because we came to know about anode, we came to know about cathode of a galvanic cell, and our basic knowledge tells us that at anode there is always oxidation, at cathode there is always reduction. And what is oxidation? That is removal of electrons. What is reduction? That is gaining of electrons. So, which electrode is anode? The one which is written to the left side. Which electrode is cathode? The one which is written to the right side. And then at anode we have to write oxidation, at cathode there is reduction. So, everything will be clear if we follow all these conventions to write a cell or formula. Now, we will take one example of this seventh rule. The seventh rule is we have to write solution of ions first, then a vertical line, and then solid. Now, this order is reversed when this order is reversed when the electrode acts as anode in the cell. That means for anode, we have to write this first and this afterwards. Zn, vertical line, Zn plus 2. But for cathode, first ion and then the solid electrode. In case of anode, exactly reverse will be the case. Let us take one example. The cell, suppose, is composed of magnesium as anode and silver as cathode. These are the two half cells. And that means magnesium strip is dipped in the solution of magnesium ions. And magnesium, it is in the second group, so it will donate 2 electrons if it is anode, because at anode there is oxidation. So Mg will be dipped in the solution of, suppose MgSO4, but we will not write SO4. We require only Mg plus 2. So Mg, single vertical line, Mg plus 2 will be anode. At cathode there is Ag. To write cathode, we have to use this type of convention. Then first the ions, then a vertical line, then solid line. So for Ag, we will write Ag plus single vertical line. Thus, by using magnesium and silver, we can write the conventions like this. Just we have to connect them by using double vertical line to write complete cell formula. So magnesium will be anode, but while writing the formula, Mg solid will come first, then vertical line, and then Mg plus 2 with its concentration in bracket, that is 1 molar. In the same way, silver, Ag and Ag plus, the convention of cathode will be same. That means first the ions and then the electrode. Hence, the formula or the cell is represented as Mg solid vertical line Mg plus 2 in bracket 1 mole, double vertical line Ag plus in bracket 1 mole, single vertical line Ag solid. So this will be the representation of a cell. Understood? Just go through all the conventions to understand it in a better way and try to write the formula. So assignment will be same. Write the cell formula considering copper as anode and zinc as cathode with 1 molar concentration each. So like Mg will become Mg plus 2, same way you have to find out copper Cu will become what? By considering its valency. In the same way zinc and its ions. Write on the cell formula, and that is the assignment for this time. Thank you.